Good morning, students. Today we are going to see how to reduce the quadratic form to canonical form by using orthogonal condition. This is under module 1. We are going to see how we are going to reduce the quadratic form to canonical form. First, the given quadratic form is converted to matrix. See the question. Reduce the quadratic form x square plus y square plus z square minus 2 yz minus 2 yz minus 2 zx into canonical form using orthogonal transformation. Also discuss the nature of the quadratic form. First, the given quadratic form is x square plus y square plus z square minus 2xy. Take this as quadratic form, and now we are going to convert this as matrix. First, you have to write the coefficient of x1 square here, coefficient of xy square and coefficient of z square. Next here 1 by 2 into coefficient of xy. What is xy here? Minus 2. So, coefficient of xy is 1 by 2 into minus 2. We are getting minus 1. This is here. So similarly here 1 by 2 into coefficient of xz. What is xz? Minus 2. Coefficient of xz is minus 2. 1 by 2 into minus 2. We are cancelling this. We are getting minus 1. So we are getting here is minus 1. Similarly, we find out the matrix. Next, we are going to find the equation of the characteristic equation. So first, we are going to find S1. S1 is sum of the diagonals. Already you know S1, S2, S3 is equal to 3. Next, S2 is determinant of A. Sorry, S2 is minor of main diagonals. First, you have to delete the first minor and the second minor and the third minor. So first minor, if first leave the first row and first column, you are getting 1 minus 1 minus 1 1. Next, plus symbol, you are getting this value 1 minus 1 and minus 1 1, and the third minor is 1 minus 1. Leave the last row and the last column, you are getting the value is 1 minus 1 minus 1 1. So finally you are getting the answer is 0. Next, S3. S3 is determinant of A. Determinant of A, you can use your calculator and find the determinant value is 4. Use calculator, go to the matrix mode and find the determinant value. Next, you are going to substitute S1, S2, S3 in the characteristic equation. What we are getting? Lambda cube minus 3 lambda square plus 0 lambda plus 4 equal to 0. Next, we are going to find the eigen value. What is the eigen value? Lambda 1 is minus 1, lambda 2, 2 and lambda. How we are getting the eigen value? Solving this equation. Use your use your calculator. Go to the equation mode and choose degree 3, and you are going to substitute A is 1, B is minus 3 and C is 0 and D is 4. You are getting the answer is, first one you are getting x1 is minus 1, x2 is 2 and x3. Again go to the problem. So the second value is repeated 1. Next, we are going to find the vector. Each and every eigenvalue, there is an eigenvector. What is the formula for eigenvector? That is A minus lambda I into x equal to 0. That is the formula for eigenvector. A minus lambda into x equal to 0. A is the given matrix and you have to minus lambda in the diagonal elements, and the other elements are the same, x1, x2, x3 and 0, 0, 0. Next, case 1. Here we are going to deal 3 cases. Case 1, case 2 and case 3. Case 1, lambda having the value minus 1. Now I am going to substitute lambda value in equation I. This is the common equation. So you are getting 1 minus of minus 1. So plus 1 we are getting 2. This is 2. And similarly we are getting the matrices 2 minus 1 minus 1 and x1, x2, x3, 0, 0, 0. So you are going to form the equation first row into first column. minus 2x1 minus x2 minus x3 equal to 0. Similarly, second row column minus x1 minus x2 minus x3 0. Third row third column minus x1 minus x2 plus 2x3 equal to 0. Here next step is we are going to see the equation. The coefficient of all the equations is same, then the equation is said to be same. Otherwise the equations are different. So we are going to use cross multiplication rule. Please refer the previous class for finding eigenvector and eigenvalue x1, x2, x3, and we start with this is first equation and this is from the second equation. Start with middle value x2, x3, x1 and x. This is the first equation coefficients, and second equation coefficient is middle value is 2 and x3 is minus 1 and x1 is minus 1 and end with middle value. Next x1 divided by, we are cross multiplying this 1 plus 2. Here now cross multiplying this 1 minus 1 to minus 1 is plus 1 and then minus 2. Here 4 minus 1. So we are getting the answer as x1 by 3, x2 by 3 and x3 by. Divided by 3 we are getting first eigenvector is capital X1 equal to 1 1 1. Next similarly, case 2. Case 2 is what? Lambda having the value is 2. I am going to substitute in the basic equation, that is I. We are getting the equation like this. See here, all the three equations are same. So, we are going to substitute the x1 equal to 0. All the equations are same. So, we are going to put x1 is 0 in any one of the equation. In equation 1. Then x2 minus x3 equal to 0. x2 going to that side. x2 is equal to minus x3. And cross multiplying the coefficients, you are getting the answer is, already we put x1 0, x2 value and x3 value. Next, case 3. Case 3 is the same eigen value, that is lambda 3 equal to 2. Now we are going to, because the given matrix is symmetric matrix, so we are going to use orthogonal condition. Orthogonal condition. Let us take x3 is LMN. So orthogonal condition is what? x1 transpose x3 0, x2 transpose x3 0. So x1 value and element and x2 transpose element. Just you have to multiply the equation L plus M equal to 0. L minus M plus N equal to 0. The same rule also we are going to follow. The equations are same or different. Here the equations are different. So cross multiplication rule L, M, N, and then start with the middle value and end with middle value. And the second equation coefficients we are taking. Next element value is, you are cross multiplying this 1 plus 1, 0 minus 1 and 1 minus. So getting the x3 value is 2 minus 1 minus 1. This is the third eigenvector. This is the second eigenvector. Next, we are going to check the orthogonal condition. We are going to check the orthogonal condition. What is the orthogonal condition? x1 transpose x2 equal to 0 and x2 transpose x3 0 and x3 transpose x1 0. This is the orthogonal condition. Transpose means what? Row becomes column. So I am going to write the first eigenvector in the column wise 1 1 1 and we are multiplying this, you are getting 0. Similarly, we have to check other two conditions. So all the conditions are verified. Therefore, the orthogonal condition is satisfied. Orthogonal condition is satisfied. Next move on to the diagonalization. What is diagonalization formula? D equal to n transpose an. Now we are going to form the normalized model matrix, that is n, and A is the given matrix. So now we are going to form the normalized model matrix. How we form the normalized model matrix? Using three eigenvectors, that is x1, x2 and x3. What is x1? x1 equal to x1 equal to 1, 1, 1 and x2 equal to 0, minus 1, 1 and x3 equal to 2, minus 1, minus 1. First you are going to I'm going to use the first eigenvector, that is 1, 1, 1. How we are going to form the normalized model matrix? First column we are taking the first eigenvector x1, first value, that is divided by the square root of all the values, that is 1 square, 1 square and 1 square. Similarly the second value is 1 divided by the same denominator. Third is 1. Third is 1. So we are getting 1 divided by the same denominator. Similarly, we are taking the second eigenvector, that is x2. x2 what is here? 0. So 0 divided by the square root of all the values, that is 0 square plus minus 1 square plus 1 square. That is appear in the denominator. And next minus 1. Here also minus 1 divided by same denominator. And 1 divided by the same denominator. Next we are going to take similarly capital X3, that is the third eigenvector, 2. 2 so that is comes in the numerator and divided by the square root of all the values, 2 square minus 1 square plus minus 1 square. So you are getting the third column. So we are simplifying this. We are getting n equal to 1 by root 3, 1 by root 3 and 1 by root 3, 0 minus 1 by root 2, 1 by root 2, 2 by root 6, minus 1 by root 6 and minus 1 by root 6. Next we are going to find the n transpose. What is n transpose? Row becomes column. Next I am going to substitute all the three values, that is n transpose A and n in the diagonalization form. We are getting, you are multiplying these three matrix using your calculator. You are getting the final answer is triangular matrix, that is minus 1 0 0 0 2 0 0 0 2. These are all the eigen values. Lambda 1 equal to minus 1, lambda 2 equal to 2, lambda 3 equal to 2. This is the eigenvalue or the just the diagonal elements, and the remaining values are 0. This is the final answer, that is the diagonalization. Next we are going to find the canonical form. Canonical form. This is the formula for the canonical form: y1, y2, y3 into capital D, that is diagonalization, which is equal to, into y1, y2, y3. Now I am going to substitute the diagonalization value and we are going to row into column. We are multiplying this. We are getting the final answer is canonical form is minus y1 square plus y2 square plus 2y3 square. Finally, we are going to check the nature of the quadratic form. First, we are going to find the index. Index is, yes, the number of positive eigenvalue. Number of positive eigenvalues. That is index is 2 and rank is 3, and then signature formula is 2s minus r, 2 into 2 minus 3 is, we are getting the answer is 1. The quadratic form is indefinite because one of the eigenvalue is positive and the other is negative. So the quadratic form is said to be indefinite. Okay. Thank you.